Hello, my name is Federico Battiston and I'm a PhD student at Queen Mary University of London under the supervision of Vito Latora, where I work on complex systems, but more in particular on the structure and dynamics of multilayer systems, which are relational systems whose basic units may be connected by a variety of different relationships. And so far, I've been mainly working at a theoretical level on such systems, for instance by suggesting structural measures for their analysis, or by analyzing dynamical processes taking places on top of them, such as random walks or opinion dynamics. But since now on, I would like to work at a more applied level, and in particular, I would like to apply the multilayer framework to the case of the human brain, which is a very good candidate for a multilayer analysis. Indeed, we have information about the physical connections among the different brain regions, with this information to be encoded into the so-called structural layer, but we also have information among the different activities of the regions and their functional correlations, with this information to be encoded in the functional layer. And of course, the new challenge is trying to combine these different types of information in order to better understand the system as a whole. But in order to perform this kind of research, I cannot work alone, but I need to collaborate with somebody who is in touch with the patients, who is able to collect the data, to process the data, and even more importantly, to speak and analyze the data in the same language of complex systems as I do. And this is why I would be very happy to collaborate with Jérémy.
Hello everybody, my name is Jérémy Guillon and I'm a PhD student at the Brain and Spine Institute at the Pitié-Salpêtrière Hospital in Paris. I'm working under the supervision of Fabrizio De Vicofalani and Mario Chavez on brain connectivity. So brain connectivity is a field laying at the intersection between three main fields: neuroscience, computer science and signal processing, and of course complex system science. So until now I've been mainly working on building those brain connectivity networks, meaning going from a brain electromagnetic signal or brain images to graphs. But I was always considering them independently, meaning at a single layer level. But since the brain is well known to show multiple types of communications, such as communications using different frequency bands, for example, I would like to go further into the analysis of those types of communications and use the multi-layer framework. That's why having someone like Federico Battiston on my side would be a great opportunity for both of us. So as preliminary results, we were able to show that in some cases, differences in groups could only be seen when using all the subject's brain network at once in a multiplex topology. So for that, we built a multiplex for each subject, where each layer in the multiplex corresponded to a frequency band specific brain network, such as an alpha or beta band specific brain network. And we used to compare groups very simple indices such as clustering coefficient or participation coefficient that were used to describe the multiplex's topology.
We would like to apply a methodology which I recently developed in London, which is able to unveil the core periphery structure of a multilayer system to the case of the multilayer human brain. Such method is based on a generalization of the concept of rich core recently suggested by Mondragon, according to which for each node we can distinguish the links towards poorer nodes and richer nodes, and by ranking nodes according to their richness and by looking at the number of links towards richer nodes, the system naturally splits into a core and into a periphery. And of course, if we have a multi-layer system, we can perform this analysis on the different layers, but in such case we end up with many different cores, one for each layer. And instead, the new challenge here is trying to correctly integrate the different information and contribution of the different layers of our system in order to correctly determine the unique multi-layer core periphery structure of our system, with here the core of our system shown in red and the periphery in blue. So to conclude, our idea is to work on characterizing the structure of the multilayer human brain, and in particular unveiling its multi-level core periphery. And we hope that our research will have also medical implications and will help distinguish control subjects from unhealthy patients, which are undistinguishable with the current tools used in neuroscience. And as a timetable, I'm planning to move to Paris to work on this with Jérémy by the end of September, right after the end of the Conference on Complex Systems in Amsterdam that both Jérémy and I are planning to attend. Thank you very much for your attention.